Hey there, Math 126 fans. We're about to embark on working with polar coordinates, and that's going to involve a little bit of trig. And I want to show you here that if you know this unit circle, you're going to be able to do a whole bunch of things really fast. These are all part of homework questions in the next section. These should each take, those homework problems should take just a few moments if you know your unit circle. But over the last few terms, I've noticed that people stop and they're telling me they're stuck on these questions. So we'll talk about those a bit in class, but these problems are giving an angle. And I find that some students don't know where that angle is on the unit circle, and because of it, the problem that should have been easy is hard. So you might ask yourself, do you know where those angles are? The other thing is, if I give you an x and a y on the unit circle, do you know how to find the angle? Okay, so in these problems, they're all giving you nice angles. So let's recap a couple small things, and I'll try to do this as quickly as I can. But basically, all you need to know is this, that sine of theta is defined to be opposite over hypotenuse for a right triangle with angle theta. That's where all of this started. It doesn't matter how big or small you draw that triangle, you're going to get the same ratio. And that cosine of theta, sorry to go way back, but I need to say this. Once we know those two trig values, we know all of them, because we can define the rest in terms of those two ratios. So we can define this to be sine over cosine. And then the others we can flip. So we can define cosecant is hypotenuse over opposite, or 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. And sometimes we put parentheses here, sometimes we don't. Okay, so that's it. So the reason I'm saying that is, if you know the values of these functions, then you also know the values of the others. Okay? So what do we do if we go past 90 degrees? Well, then we define it in terms of the corresponding spot on the unit circle. So the reason that there is a triangle here, if you don't see it, and there is this angle here, 30 degrees, and this holds that value. So if you don't know this about the unit circle, the main observation was that the x-coordinate, the reason we call it the unit circle is because the radius is 1. By making the radius, the hypotenuse, 1, we make it so that the opposite and the adjacent are the values. So anyways, the key thing you need to know is that the x-coordinate is cosine of whatever that angle is, and the y-coordinate is sine of whatever that angle is on the unit circle. So that gives you a visual way to remember everything. And then if you know those, you know all the rest. Okay, so the next thing I noticed that some students have forgotten is how we break things up. So let's remind about how that goes. So quick note, we call this angle 0. We call this, and if you go all the way around, we call this angle 2 pi. The rest of it is just divided up from that. So this is pi. And when you're thinking in terms of polar, which we're about to do, the most important angles are these. So we want to know those really well, because basically that's what it means to be an intercept, is you're looking in the direction of 0 or pi over 2 or pi or 3 pi over 2. We need those to know those really well. Then we have these halfway in between angles. And ultimately these are the ones that have nice values, but we're basically breaking it from here to here into 6. But this is pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And you might say, why did we skip some along the way? Well, 2 pi over 4 is what pi over 2 is, and 4 pi over 4 is that. So anyways, that's it. We actually are breaking it essentially into twelfths. we're breaking 2 pi into 12ths. But anyways, a few other things. So then we'll label a couple other nice values. These are just nice values that have well-known properties because of the triangles they correspond to. So this is pi over 6. This is pi over 3. And then you get to use symmetry around. So this is 2 pi over 3. This is 5 pi over 6. So I find a lot of students don't know that and don't have a way to recall that. Not everybody. A lot of people have this figured out. But it is well worth your while to sort of, I can generate this. But if you're doing the homework, you can just have the thing in front of you when you do these problems. Because I was talking, I made a mislabel. Okay, 4 pi over 3. That's sometimes what happens. I well, that doesn't make any sense. And then I'm able to fill in the rest. Okay, 11 pi over 6. That's it. And you can see those there. And they repeat if you go past. So the first thing is to know those. But really, if you know the first group, you can figure out the rest. You definitely want to have these memorized because we're going to be using them so much. And I think most students do. Then you can deduce based off of that. In my head, sometimes I remember that, okay, 12 pi over 6 would be 2 pi. And so right before it would be 11 pi over 6. So a few different ways to think about it. Okay, lastly, the values. So if you can remember that sine starts at 0, then you have this as well. Sine starts here. It ends at 1. Sometimes I jokingly give students this. It's not joking. It's just a goofy way to remember it. Is you go 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. You take the square root of everything and you divide by 2. So square root of 4 divided by 2 is 1. And then square root of 3 over 2, square root of 2 over 2, 1/2, 0. I always say when I was a student, I just remembered that this is smaller than this, which is smaller than this. And so I just remembered that sign goes up. So at pi over 6, sine is going to be as small as can be. So, or I thought of it as the y value. The y value is getting bigger. The y value is getting bigger. So there's a lot of different ways to remember that. Okay, so now to what actually happens. So in these problems, you're often going to be computing some value. And so the question is, do you know those values? So I always think when someone asks you, what is cosine of pi? I see this one messed up a lot. You should be thinking the x-coordinate of the unit circle right here. You should be thinking -1. It should be an immediate thing. If somebody says, what is sine of, 5 pi over 6? You should think about where is 5 pi over 6? Well, it's going to be similar to what it is for pi over 6, except on the other side. We're talking about the y-coordinate, so the y-coordinate should be the same. Again, if you have the thing in front of you, then you know the answer immediately. That's way faster than really almost anything else I can think of. Okay, it's faster than having to look up the unit circle. Just have it printed out in front of you. Okay, so then if somebody asks me what is tangent of, 7 pi, 7 pi over 4 is kind of too easy of a one. Let's pick something else, of 2 pi over 3. I think about where 2 pi over 3 is on the unit circle, and I remember that it's sine over cosine. Sine is the y-coordinate, so I just write square root of 3 over 2 over -1/2. The sine over cosine, and that's negative square root of 3. Those values are all in there. If I get to the end of an integration problem and I have secant of, I don't know, let's say pi over 3. Sometimes students say, well, I don't know the values of secants. I didn't memorize them. But this is 1 over cosine of pi over 3. So you do know that value. Cosine of pi over 3 is the x-coordinate here. So this is 1 over 1/2, which is 2. All of the answers are sitting in that unit circle. In addition, sometimes I have students that come to me and say, how would I know on a test what inverse sine of a half is? It's also in my unit circle. But now we're going the other way. We're saying, when is the y-coordinate a half? Right here. And what is the corresponding angle? Pi over 6. So I find a lot of people don't know this, but it's really valuable. Okay, so then when you're going to do the homework and it says 3 pi over 2, what you need to immediately be thinking is, this is saying looking straight down, if they give you this angle. Negative 2 pi over 3, now we haven't talked about negative yet, but negative means going the other way, so that would be right here. That's what this is. Pi over 6, we know what that is. Pi over 4, we know what that is. Negative pi over 6 is actually the same as 11 pi over 6. 7 pi over 4, we don't want that to scare us. This is saying from 3 pi over 4 to 7 pi over 4. So you can see if you know your unit circle, these are not saying something that fancy. But if you don't know your unit circle, these are hard. Similarly, there's going to be homework questions that say things like this. If x is negative 6 and y is 6. So think about that. That means it's on this line, way out here somewhere. The question asks things like, what's the angle? And I find a lot of students start trying to solve and use calculators when they can see what it is already, that it's already 3 pi over 4. Same thing for this one. It says 2 and 2 root 3. Now, that might look a little different. Maybe you have to think about what tangent is, sine over cosine. So 2 root 3 over 2. So that's what tangent would be. So when are we going to get root 3 for tangent? Tangent, it's sine over cosine, so it's right here. So this is at pi over 3. So anyways, even if these things are scaled up, we can still use the same ideas. Okay, so that's probably spent too long there, but that's something that I'll talk about in class. I hope that helps.